Hi, welcome back. Functions and graphs video, this time on domain and range. What is meant by the domain of a function? What's the definition of domain? Well, domain is the set of all possible x values. It's all the x's that are possible in a certain expression we'll explore for the idea of domain. What is meant by the range of a function? Well, that's the set of all possible y values. So that in certain circumstances, depending on the expression we have, a function might allow us to have any x values or any y values, or sometimes there are some restrictions. We'll talk through those restrictions in this video. State the domain and range of y equals square root of 3x minus 2. Now, I think you'll know from your previous studies that when you square root something, it can't be negative, and the result you get can't be negative either when you square root something. So you can't have the square root of a negative, so that means that 3x minus 2 has got to be greater than or equal to 0. You can have a square root of 0, so that's why the equals 2 is in that symbol there, a greater than or equal to. But on the whole, though, we usually need that the contents of that square root to be not negative. That's the idea there. So we can now, to get an x value for our all possible x values here, we'll solve this. So we'll add 2 both sides and then divide by 3 both sides just to solve that inequation. And so the domain in the end is x is greater than or equal to 2/3. So we knew that 3x minus 2 had to be greater than 0 because you can't have the square root of a negative. Now the range, as I said at the beginning of this example, the result when you square root something, you can't get a negative out of that as well. So you can't have square root of 16 or something or other and get a negative 4. It just doesn't work that way. So your result is going to be negative. So overall, y has to be greater than or equal to 0 as well. So that's your range. State the domain and the range of this expression here, y equals x squared minus 5. Now all real x are possible here. You can put negative numbers in there and then square them. You can put 0 in, you can put really big x values in. So there's no real restriction to what x values you can have there. So we say, that's the way we say that for the domain is all real x. Now y values are going to be restricted because this section of the function, this section here, y squared, when you square something, the lowest your result can be is 0. So if you then take away a 5, the smallest that that right hand side can have as a value is minus 5. It can't get any smaller than that. Like x squared can't be negative, so you can't get any lower than minus 5 overall on that right hand side. So x squared minus 5 must be greater than or equal to minus 5. The lowest value for x squared would be 0. So if we had 0 minus 5, that would be the lowest value that y could be in that whole arrangement. So we'd say that the range y is greater than or equal to minus 5 altogether there. So here's an interesting one. State the domain and range of y equals 1 over 3 minus 4x. Now, we knew some restrictions that we had for square roots. You know, square root can't be a negative and you can't get a negative result out of a square root. There's a thing with fractions as well that you can't have, and you can't have the bottom of any fraction to be 0. The denominator of a fraction can't be 0. So we know now that 3 minus 4x on the bottom there can't equal 0. So we have a think through that, and we can solve that. We would add 3 to both sides here, and that will cancel out on this side, leaving us with minus 4x is not equal to minus 3. I'm sorry, we'd have to minus 3 both sides. Well done, Mr. Blake. Minus 3 both sides to cancel out, and so we'd end up with minus 4 is not equal to minus 3. Then we would divide both sides by minus 4 just to get x on its own here. We're just sort of trying to isolate x. So when we divide there, we get x not equaling 4 over 3. We'd have a minus 3 over a minus 4, which would cancel out the minuses. X can't be 4 over 3. Now that's the only item, that's the only value that x can't be. We can have other x values that make very small or very big fractions out of that whole right-hand side, but we definitely can't have a value whereby the bottom of that fraction is 0. And so that's the way we say it. It's a funny way of saying it, but the domain we state as all real x. In other words, lots of x values are possible. Every other x value is possible, but this is like a condition we put on. This little symbol here, the 2 dots, it says all real x such that x is not equal to 4 over 3. That's the way we read it. And the range, all real y is possible there, so lots of different y values are possible. You can have really big and really small numbers, but yeah, so all y's are possible. It's just that particular x value that makes the bottom of the fraction 0 is the exception to the domain. Okay, domain and range of this, it's got some absolute values there. Now we know from absolute values that this whole right hand side ends up being positive, or 0 at least. So the domain, we can put any x values in there, and if we put negative x values in there, and we end up with a negative for 2x plus 3, the absolute values just make that turn into a positive. So the range, the y value, when y equals this whole right hand side here, we know that these absolute value signs, if the contents were negative, it would turn them into positives anyway. So the smallest that y can be, the right hand side can be really, is 0. So our range is y is greater than or equal to 0 on that one. Find the x and y intercepts. Now there's ways of finding x and y intercepts. An x-intercept is found when y equals 0. So what we do is we sub y equals 0 into an expression and we get an answer. In this case, if we sub y equals 0 into here, we get 0 equals x squared minus 9. Now I've just turned it around so it makes a bit more sense here. We're used to having expressions on the left hand side equaling 0. So we've got that there. Now if you remember your factorizings, you can express 9 as 3 squared, and it fits into that fancy factorizing of having one set of brackets with x plus 3 and another set of brackets with x minus 3 there. And that allows us to say, well, x equals minus 3 or 3. If you're not sure of that, have a look back at the quadratic equations video we did recently. So that's our x-intercepts. X equals minus 3 or 3. To find y-intercepts, we sub in x equals 0. There's a slightly easier proposition here. Instead of a x, we've got a 0, and y equals minus 9. Now, and so that's where we get our x and y intercept there. Okay, so this is another example where they want x and y intercepts. So we'll sub in y equals 0. This is a line, this one. It's not going to be too bad, this one. So instead of a y, we're going to replace that with a 0, and we're going to solve the rest of that expression. We get 3x minus 2 equals 0, and we'll just solve that by adding 2 to both sides and dividing 3 both sides. So we sub in y equals 0, and we solve what's left, really. The y-intercept is when x equals 0, so if we sub in, instead of an x, we'll put a 0 there, and we'll solve the rest of it. Solve a two-step equation, adding 2 again and dividing by 4 this time. That simplifies down to be y equals a half. So we've got an x-intercept of 2/3 and a y-intercept of a half. So it's like opposite land here. To find an x-intercept, you sub in y equals 0 and solve it. To find a y-intercept, you sub in x equals 0 and solve it. Okay, x and y intercepts of this one. This is a quadratic or a parabola type shape, but anyway, we can do the same sort of process here. To find an x-intercept, y equals 0. When we do that, we get this expression here, and that is a quadratic equation here, and we factorize that into x minus 3 in one bracket and x minus 2 in the other bracket. We could have done that by doing PSF here, with our product of these two numbers being 6 and our sum being minus 5. Our factors would be -2, and -3 for that. So PSF would be needed there to turn them into brackets like that. Then we say x minus 3 equals 0, or x minus 2 equals 0. And we end up with the opposite values of those. So -3 comes down to a 3, and -2 comes down to a 2. So that's two possible x-intercepts there. Y-intercept is when x equals 0. We just sub in, instead of x here and x here, we put 0 in those spots, and we are left with y equals 6. So our x-intercepts are 3 and 2, and our y-intercept is 6 there. Okay, so we saw a fair bit of domain and range, and we also explored a little bit of revision on how we find x and y intercepts, hoping those examples help you in your studies and refreshing your memory. Thanks for listening. Catch you next time.